Hey, what's up, guys? Yeah, so in this video, I want to talk about Bell inequality because previously I talked about the CHSH game and the Bell inequality with the Nobel Prize. So I guess it's interesting, and I will just talk about one perspective, which is I think is the very easy to understand. I mean, at least from this mathematical perspective, and hope you guys subscribe to my channel. Okay. So the idea is that you can imagine that there's Alice and Bob, right? So they are like if they are like far enough or whatever, there's no correlation between them, and they have like two kind of measurement, two outcome measurement. Okay, so Alice has two. Let's call it A0 and A1, and B0, and Bob has also B0 and B1, and each of AI in the classical or BI can only choose to be plus or minus one. Okay. And there's no correlation between them. So this means that Alice, whatever Alice measure on A0 cannot, it's not related to Bob B0, B1. So Alice A0 will not affect by any B0 and B1 results. And also SOS Bob. Okay, and they can compute the problem. They can compute they can compute the number called S, right? This S is basically A0, B0 plus A1, B1. Sorry, minus, let me just write it as this. So it's like it's A0 B1 plus A1 B0 minus B A1 B1. Okay, I mean it's weird that this is plus, right? I mean, but if this is plus, then basically it's A0 plus A1. Okay. Okay, so whatever probability of A0 to be plus one, this doesn't make okay, so let me just explain. So this S, right? So this is either plus or minus one, plus or minus one, plus or minus one, plus or minus one. And I can write as A0, B0 plus B1, and plus A1, B0 minus B1. Okay, so obviously that since B0 and the B1 is also always plus or minus one, so either one of it 0 or 2, right? So B0 plus B1, maybe 0 or 2, and but one of it must be 0, right? So this means that S is at most 2, right? Because if this is 2, this might mean but must be 0, then A0 must be can only achieve 1. And also S is bounded by negative 2. Okay. So if there's no correlation between them and each of must be plus or minus 1, then S obvious bounded by 2. And this is doesn't relate it to any probability that A0 to be 1 or A0 to be minus 1. However, right, because even though there's a probability, you calculate the expectation value of S still bounded by 2, because each of like must bounded by 2, right? So the total expectation value also is bounded by 2. Okay, but the idea is that in quantum mechanics, is S can be greater than 2, greater than 2. So the construction, the construction is basically as the previous CHSH video that you can construct. You can use a Bell pair. Okay. So idea is that if Alice and Bob, it really cannot communicate. There's no correlation between it. That really these guys too, right? But if they can share content, let's say they share an object called Bell pair, right? So this guy's a Bell pair. And the Alice choose A0 to be some measurement, and A1 to be some measurement, B0 to be some measurement, B1 to be some measurement. Then this will make this Bell inequality fails. Okay, so let's do some simple calculation. So you will immediately see this. So Alice pick A0 to be some observable, right? So it says Pauli Z operator, and or sigma Z, and A1 is X. Okay. So obviously that A0 is always plus or minus 1, right? The output results, A1 is also plus or minus 1. And Bob pick square root of 2, Z plus X, and B1 also square root of 2, Z minus X. So this is basically another basis. Obviously also plus or minus 1, plus or minus 1. And oh really? Yeah, because yeah, I think so, right? You can let's see, right? So if z plus x, basically it's like it's doing some stupid quantum mechanics. Right, x is 1, 1, 0, so it's 1, 1, 1 minus 1. Okay, now obviously that eigenvalue is also plus or minus 1, right? You can check this. Uh, yeah, I mean, let's see. Sorry, sorry, I'm stupid. Just too quick, right? This is the hard one, right? So let's do this, right? So you can like, right? Yes, this square root of 2. I just want to make sure that this is right. So you can check the eigenvalue of it. So it's 1 over square root of 2 minus lambda minus 1 divided by square root of 2 minus 1. Sorry, minus lambda minus half. And so this is like lambda squared minus half is 0. Lambda squared is 1. So lambda is also plus or minus 1. Okay. So you can prove that. So B0 has also eigenvalue plus or minus 1. And the B1 is also eigenvalue plus or minus 1. Well, this stupid thing doesn't, we don't need this. Okay. Okay. So from this perspective that one can calculate a Bell pair. One can calculate its potential value of A0, B0, right? So it's half of square root of 2. Z square is identity, right? Plus ZX. Okay, and right, so if you can calculate the A0, B0 econ phi, right, will be 1 over square root of 2 phi. So notice that phi is half of square root of 0, 0 plus 1, 1. Okay, and plus ZX, right? If you ZX here, if you ZX here, right? If you ZX here, that become like this guy become okay. So this guy become another this guy will be ZX econ 0, 0. So Z will still fix, X will get a 1, right? So become 0, 1. And ZX econ 1, 1 will get Z will get minus 1, right? But X will flip 1, right? So it's basically 1, 0. Okay. But it's 0, 1 and 1, 0, right? Doesn't also go down to this original phi. Okay. So what I'm saying is that if you add phi here, right? If you add phi here, you only get 1 over square root of 2. It's basically these terms, this term econ phi and the phi inner product will be 0, right? Because this guy is 0, 1 and the minus 1, 0. So basically ZX, what I'm saying is that ZX phi is 0, right? Just by this calculation. Okay, and then from here, that's easy to prove, right? So now I can calculate phi of A0, B1, phi. Right, so it's z squared minus zx is 0, so I get 1 over square root 2. Okay, now let's calculate phi A1, B0, phi. So it's xz, right? Xz is 0, but x squared is 1. So it's 1 divided by square root 2. Okay, and the phi A1, B1, phi. So A1 zx is 0, but minus x squared is minus identity. So it's minus 1 of square root of 2. Okay, if you calculate the quantity s, its potential value, you get 1, 1, 1, minus 1, right? So you get 2 divided by square root of 2, which is square root of, sorry, 4 divided by square root of 2, square root of 2, so it's 2 square root of 2 greater than 2. Okay, so this is spelling inequality, right? So the quantum has like higher value basically it's 2 times square root 2 greater than 2. Okay. And yeah, this is the constructive proof. And yeah, you just simple calculation. And there's a fact that I will prove maybe in the next video, that the 2 square root of 2 is optimal. Okay, so one can like brute force prove this is true. Okay, so see you guys next videos.